Hello, welcome to my YouTube channel. My name is Irfan and today we are diving into the world of data visualization using Python. I shall use a real-time iris dataset from Kaggle. So let's get started. The iris dataset is a classic in the field of data science. It consists of measurements from 150 iris flowers from 3 different species. For each flower, we have measurements of sepal length, sepal width, petal length, and petal width. The dataset is labeled, meaning we know the species of each flower. So first of all, we need to get the data. So I got this data from the Kaggle website. To get the data, you can go to the Kaggle website and search for iris species. And here you can download the data and load it in your Python environment. So let's get back to our Jupyter notebook. So I already have created a Python notebook in Visual Studio Code. If you don't know how to install Python in Visual Studio Code, you can watch my another video. I have provided the link into the description. So as you can see in this folder, I already have my iris data with iris.csv. First of all, let's load our dataset. We shall be using Python for this tutorial with the libraries pandas for data manipulation and Seaborn and Matplotlib for data visualization. So first of all, I will import the pandas library. As I shall be using the pandas library again and again, so typing pandas is difficult. So we say import pandas as pd. So instead of using pandas, we can use pd. Next, we shall load the iris flower dataset, which is in the .csv file, and store it into the variable iris. To read a CSV file, you can use built-in function in pandas read_CSV. And inside parentheses, you can provide the name of the data. Now let's see what is inside this data. Jupyter Notebook prints the result of the last thing you do. So let's say I want to see the first 5 entries. So in pandas, we have a function .head. So we will say iris.head. And if you execute this cell, you will see the first 5 entries of the data. So in this data, we have the ID of each flower, sepal length in centimeter, sepal width in centimeter, petal length in centimeter, and petal width in centimeter. And then the species of each flower. As you can see, the dataset is nicely organized, making it great for beginners and professionals alike. Let's see how many examples we have for each species in this dataset. So we'll select the species column and then say value counts. If we execute, you can see there are 3 species in this dataset: Setosa, versicolor, and virginica. And we have 50 observations for all the 3 species. If you want to see the shape of the dataset, we can say iris.shape. So this says there are 150 observations, and in total there are 6 features, 6 columns. Now let's start the data visualization for this data. Before we start the data visualization, we need to import some important libraries. So we shall import Seaborn, a Python graphing library, and Matplotlib for this data visualization. And if you want to remove any kind of warning during the plot, you can use the function warnings. We say import. Sometimes there are some functions in these libraries which are getting old and they are going to remove in the next versions. So it throws some warnings. If you don't want to see those warnings, you can use the warning library to ignore that. And you can also set what kind of background you want to see in your plots. So I will say sns.set, and you can set the style. There is a dark, white, blue. So I will use the white one. So it can also use different color codes. Let's execute. So all of our libraries has been imported. Now we can start the data visualization. So let's start with the basic scatter plot of sepal length and sepal width. This kind of plot is useful to understand the relationship between 2 variables. In our case, we can see if there is any correlation between the sepal length and sepal width. The first way we can plot things is using the .plot extension from pandas data frame without using any other library. For example, I say iris.plot. So the .plot is a built-in function in pandas data frame. If you don't want to use any other library, you can use it. But remember, there are limited plot functions in pandas data frame. So we have to use Seaborn and Matplotlib library as well. So the first argument, you need to define what type of plot you want to make. So I want to make a scatter plot, and then you need to specify which variable you want to see on X and which variable you want to see on Y. So on X-axis, I want to see the sepal length in centimeter, and on Y-axis, I want to see sepal width in centimeter. And if we run it, so I think the variable name is not correct. It's sepal length. The M is small for centimeter. So we got this plot. So from this plot, you can see there is not a strong relationship between a sepal length and sepal width. We can also use the Seaborn library to make the similar plot. Why I'm showing you different ways to make the same plot. So sometimes some people feel comfortable with one type of plot and one type of library. So if you know all the methods, you can use them. So in Seaborn, we can say SNS scatter plot. And inside, again, first of all, you need to specify the x-axis and then the y-axis. So x-axis is sepal length in centimeter and y-axis is sepal width. But here you need to specify which data you are using for plot. So you can say the data is iris. And we can say plt.show. This command is used to show the plot. So you can see, again, we got the same plot, but using Seaborn library. So as there is no relationship, but we can see some clusters formation, which may indicate the different species of the iris flowers. One piece of information missing in the plot above is what species each plot is. Now let's color code our scatter plot based on species so that we can recognize which data point is representing each species. To do that, we just need to add one more argument in our scatter plot. So I just copy paste the code, and here you need to specify the variable hui. So in hui, I want to see species. If I run it, oh, I'm missing comma here. The figure size is small. Let me change the size of the figure. So I can say plt.figure. Okay. Now the figure size is quite good. So now you can see when I add a variable hui equal to species, from each data point, I can also see to which species the data points belong. For example, the blue one, it's Setosa, the orange one is vesicolor, and the green one is virginica. So now we can distinguish between different species and examine their characteristics. This kind of plot is essential in understanding the features of different categories in our dataset. So you can see how the data points are clustered based on the species. Each species seems to have its own unique range of sepal length and width, and we can classify them based on sepal length and sepal width. Now let's see the box plot now. Box plots provide a visual summary of the data, such as the median, quartiles, and outliers. They are an excellent way to understand the distribution and variability of the data. So we can see the box plot for all the features, and we can also see the box plot for individual features in the dataset. So let's say on the x-axis, I want to see all the species, and on the y-axis, I want to see the petal length in centimeter. So in Seaborn, you can use the command sns.boxplot, and inside on the x-axis, I want to see species. On the y-axis, I want to see the petal length in centimeter. And then definitely you need to specify which data are you using. So data equal to iris, and then plt.show. And if you want to increase the size of the figure, you have to use plt.figure. Figure size is equal to 10 into 8. So here you can see there are 3 different box plots for the 3 different species based on the petal length of the flower. For example, you can see for the species virginica, this middle line is called the median value. So the median value of the petal length in centimeter is high for virginica, but the median value for the Setosa is lowest for the petal length centimeter. So this is giving you an information that if you want to compare the petal length in centimeter for all the 3 species, you can easily make a comparison. The petal length in centimeter is highest for virginica. It is intermediate for vesicolor, and it is minimum for Setosa. And box plot also helps you to find out the outliers. Any data point outside these horizontal lines is called the outlier. Okay, one way to extend this plot is adding a layer of individual points on top of it through Seaborn strict plot. So how we do that? So we can say, so I want to add all the data points on these box plots. I will store the first plot into a variable axis and then add a second plot on this one. So I will say ax equal to sns dot strict plot, and inside everything is the same. So you can just copy paste, and if we run it, so you can see now it is also plotting all the data points for each box plot, indicating that which data point is lying at what point. Perfect. However, here we are making 2 plots. One is a box plot and the other one is the corresponding data points, which tells us how the data is scattered and at what location. Instead of looking at these two plots, we can combine both of these using a Violin Plot and Seaborn. So let's see how to make a Violin Plot. So a Violin Plot combines the benefits of the previous two plots and simplify them. Let's first plot the Violin Plot. SNS.Violin Plot, and on x-axis I want to see the species, and on y-axis I want to see the petal length. And you have to specify that you are using iris dataset, and then plt.show. And definitely you can set the figure size if you like. If you run it, so you got this plot. So this plot exactly gives the same information like this two plots. So the denser regions of the data are fatter, means where most of the data points are lying, they will be fatter. Where the data point is less, they will be thinner. So you can see for species Setosa, most of the data points is lying around the median value. Similarly, for this one, the Violin Plot is not as fatter as this one. Okay, so let's see the KDE plot now. So KDE plot is useful for looking at univariate relationships. Means if you want to see how one feature is varying, then you can use a KDE plot. For example, I can say sns.kde plot, and inside we just want to give one variable. I gave petal length in centimeter, and then you need to specify the data is iris, and then we have plt.show. If we run it, you got this plot. However, if you want to see how the petal length in centimeter is distributed for different species, we can add a new variable called hui, and here you can specify species. So hui parameter in Seaborn is always used to see the different categories, how the data is distributed for different categories. Okay, so you can see here now we have three different KDE plot for petal length in centimeter. So this is telling us that for iris setosa, the petal length is distributed between 1 and 2, and for iris versicolor, the petal length in centimeter is distributed between 3 and 5. And for Virginica, it is distributed between 4 and 7.5. This also helps us to understand that how we can categorize based on the petal length in centimeter to classify different flower species. So let's move to the PairPlot function in Seaborn. So what is a PairPlot? This function creates a grid of scatter plots for each pair of features and histograms for each individual features. It means you don't need to make a scatter plot for individual features one by one. Using PairPlot, it will make a scatter plot for all the features inside your dataset. So let's try to see how does it work. So we say sns.PairPlot, and if we look at our dataset, we have these columns. So ID is just a unique identifier, so it has nothing to do with our dataset. So we can drop it and we can make a PairPlot for sepal length, width, petal length, petal width, and species. So we can say iris dot drop, and you have to specify which column you want to drop. So you want to drop ID, and then you have to specify the axis. Axis equal to 1 mean you want to drop the column. So here we drop the ID column, and then apart from ID, it will make the PairPlot for all the features. So you can see we got a PairPlot for all the features. We got the plot of sepal length in centimeter with the sepal width, petal length, and petal width. And the plot of the sepal length in centimeter with itself is shown as a distribution. Let's say you want to see all the data points distributed for each species. So you can specify hui equal to species, and we run it again. So now you can see it plot a scatter plot for all the features and all the data points. They are colored based on each species. So you don't need to make a separate plot. All the information you get from one single plot, and it helps you out how you can classify three different species based on their petal length, petal width, sepal length, and sepal width. Okay, let's move to the last part of this tutorial, which is called the correlation matrix. For example, you want to see the correlation between all the features in your dataset. So how to do that? So we can calculate the correlation using a command iris.correlation. This will calculate the correlation of all the features. So if I visualize it, you can see it will find the correlation between all the features. So the correlation of the sepal length with itself will be 1. Definitely they are highly correlated. And then the correlation between sepal length in centimeter and sepal width is negative, means they are correlated in a negative way. And then the sepal length in centimeter and petal length in centimeter, they are highly correlated in the positive side. So correlation value vary from -1 to 1. -1 means the highest negative correlation, +1 means the highest positive correlation, and 0 means no correlation at all, means they are completely different. If you want to see this correlation plot in a more appealing way, you can use heat map. So we can say sns.heatmap, and inside you can provide your correlation matrix data. And if you want to see the value during the plot, you can say annotate equal to true. So here you can see it makes a heat map indicating the correlation between all the features using different colors. The color doesn't look good. So let's say you want to change the color. So you can say CMap equal to blue. It's blues. So the one with the dark color is highly correlated and the one with the light color is highly negatively correlated. So heat map clearly shows the correlation between different features. Darker colors indicate high correlation. Visualization like these help us to decide which features to use for predictive modeling. Highly correlated features can often be reduced to a single one, simplifying the model while preserving its accuracy. Okay, that's a wrap for today's video. I hope this tutorial has given you a good start on visualizing data with Python and the Iris dataset. There is still much more to explore, so don't stop here. You can try creating other types of plots or experiment with different datasets. The more you practice, the more you shall understand about the data, and the better your visualizations will become. If you have any question, don't hesitate to ask in the comments. I'm here to help you on your data science journey. Thanks for watching, and don't forget to like, share, and subscribe to my channel for more tutorials like this one. I shall see you in the next video. Until then, happy coding.